Hi everyone, this video lesson is titled The Triangle Inequality, and it's from Chapter 5, Lesson 4. So if we take a look here, of course a triangle has three sides. Let's notice about the length of the two shorter sides compared to the length of the larger side. So we're going to say A, B, and B, C are the two smaller sides, and we're going to say that AC is the longest side. Okay, so let's open up this Sketchpad file and see what we see. So here, of course, AB is the longest side. So this green AB right here, that's the longest side. Right now it's 13.26 centimeters. And BC and CA, when you add them up, you get 18.42. So notice how the sum of the two smaller sides, 14.82, is larger than the other side, 13.26. This one is larger than this one. Okay? So let's change our triangle around. Let's lengthen the length of AB, shall we? And let's see what happens. I'm lengthening AB, but as you can see, then I'm also lengthening BC. So the sum of the two shorter sides is still larger than the third side. Is there any way that I can make the third side larger than the sum of the two smaller sides? Well, let's lengthen this out a little bit more. But as I lengthen the segment AB, I'm also lengthening the segment of CA. So I still have this side, the sum of those two sides, larger than the longest side. So no matter what I do to this triangle, the two smaller sides, their sum will always be longer than the third. It's getting really close right now, 28.23, 28.19, but of course 0.23 is still bigger than 0.19. The only way you can do it is if you make basically two segments, right? And now that isn't a triangle anymore, that's just two lines. So if you're going to have a triangle, what always has to happen is the sum of the two shorter sides will always be greater than the third side. So that is what this states right here. It's always going to be greater than. So the sum of the lengths of any two sides of a triangle is always greater than the length of the third side. A triangle cannot exist if the two smaller sides are less than the third side. Then we don't even have a triangle at all. So here's this question. Can these side lengths make a triangle? Well, if a triangle exists, the two smaller sides, their sum has to be greater than the third side. So the two smaller sides are 15 and 20. That sum has to be greater than the longest side, 35. Is this true or false? Is 35 greater than 35? Of course not. That is a false statement. So can these sides make a triangle? The answer is no. If you have a segment that's 15 inches and a segment that is 20 inches and a segment is 35 inches, you cannot make a triangle with those three lengths. How about with lengths of 5, 10, and 7? Well, the sum of the two shorter sides have to be greater than the third side. Is 5 and 7, the two shorter sides, greater than 10? Is 12 greater than 10? Of course it is. So this one is a yes. If you have a segment that is 5 miles long and 10 miles long and 7 miles long, you can make a triangle with those three lengths. So now we're at the question, find the range of values of the third side of a triangle with two sides that are 6 centimeters and 11 centimeters. So if I had a segment of 1, 6, or a triangle with segments 1, 6, and 11, can I make a triangle? Does 1 plus 6, is that greater than 11? No, I cannot have 1 centimeter. How about 2 centimeters? How about 2 plus 6? Is that greater than 11? No, 8 is not greater than 11. So what is the smallest side that I could have that would make a triangle with 6 and 11? If I had a 5 plus 6, is that greater than 11? Again, that answer is no. But what if my answer was 5.1? What if my third side was 5.1 centimeters? Now, 11.1 is greater than 11. So at like just bigger than 5 is the third side of my triangle. So I could have a third side of my triangle be 5.5, 5.9. I could have it be 6. I could have it be 7. I could have it be 8. I could have it be 9. I could have all of these different side lengths and still make a triangle, but at least has to be bigger than 5. However, could I have a side length of 6, 11, and 85 centimeters? No, because if these were the two shorter sides, if 6 plus 11 were the two shorter sides, that would have to be bigger than the third side. So like I said, I couldn't have a side of 30 centimeters because 6 plus 11 has to be bigger than the third side. So could I have 25 centimeters? Is 6 plus 11 greater than 25? No, it's not. Right? So 6 plus 11, could I have that, my third side, be 18? I'm getting closer. 6 plus 11 is 17. So even if I had a length of 17, I could not have a triangle because the sum of the two short sides have to be greater than the third. However, what if it was just less than 17? What if it was 16.9? Could I have a triangle that has side lengths of 6 centimeters, 11 centimeters, and 16.9 centimeters? Yes, you could, because 17 is greater than 16.9. So basically, for a triangle to exist, the smallest third piece could be 5.1. And the largest third piece, third segment, could be 16.9. I could have side lengths anywhere in between these two, but if it gets 5 or less, I can't form a triangle. Or if it gets 17 or more, I cannot have a triangle. So I could have something in between. So here's how we write this, and here's maybe how I want you to show your work on this one. Let's get rid of all my doodling here. In order to find the range of the values of the third side, it's very simple. All you simply do is subtract the two numbers. 11 minus 6 is 5. So my third side, here's my third side. My third side has to be bigger than 5. So this has to be larger than 5. But we said that my third side also can't be very large. It has to be less than, I think we said, like 16.9 or 17. It has to be less than 17. So that's what we do when we add these two. So 11 plus 6 is 17. So my third side has to be less than 17 and has to be greater than 5. So that's how we write this. 5 is less than the third side, and the third side has to be less than 17. So my third side could be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and any decimal of those, but it cannot be 5 or less. It cannot be 17 or more. So that's how you write this for these questions. Let me know if you have any questions on this when you get to class tomorrow.